Let's take a look at this problem. We are given a function such that for all real numbers x, f of x is equal to x squared minus x minus 1. Find the value of f of 0. Before we move on, don't forget to give a like, subscribe to our channel, and turn on post notifications. This problem can be solved in just one very simple trick. We only have to consider f of x. I can express this expression in two different ways. First is that by focusing on the most inner part of f of x, I can say from the original equation it's just like replacing this x by f of x. And so we have on one hand that to be equal to f of x all squared minus f of x plus 1. So that's the first way of rewriting f of x. Now, on the other hand, I can focus on applying the function f on f of x, which means I'm applying the function f on this quadratic expression x squared minus x plus 1. So that means it's on the other hand equal to f of x squared minus x plus 1. So because both the red and the blue expressions are equal to f of x, they are equal to. Now I can use this to find values of f. For this, we notice that if I replace x by a certain value, I can have these x and x squared minus x plus 1 to be equal, and our only choice is x equals 1. When x equals 1, f of 1 all squared minus f of 1 plus 1 equals f of 1 minus 1 plus 1, which is also f of 1. That means I have a quadratic equation about f of 1. And by solving, we know f of 1, no matter what, is always equal to 1. And this is going to be very useful, because what we have to do is to solve for the value of f of 0. Why not we try to put x equals 0, and then you will see how the fact that f of 1 equals 1 can help. Putting x equals 0, we can say f of 0 all squared minus f of 0 plus 1 equals f of 0 minus 0 plus 1. Now, the numbers inside the bracket is equal to 1, so the right side is also equal to 1. And now we have a quadratic equation about f of 0. From this, f of 0 is either 0 or 1. So at this point, we have two candidates for our final answer. Of course, we can take both, but we still have to check each of them one by one. To do this, I'm going to put x equals 0 into our original equation right at the very beginning, which is that f of 0 have to be equal to 0 squared minus 0 plus 1. That means double f of 0 has to be equal to 1. Now, just if f of 0 remains 0, that means no matter how many times we go through this function f with 0 as the input, we will still have 0 as the output. In other words, at x equals 0, f is actually constant. But by going through this 2 times, the output is not constant anymore. So that means we have to reject this case. So the only possible case remaining is that f of 0 equals 1. And of course, if f of 0 equals 1, then it matches the solution. So that will be our final answer. Please feel free to share ideas in the comments. Thank you for watching. See you next time.